Good morning. This is second class on semiconductors. In this class, we will conceptualize energy gap, and we will also observe why energy gap is less in conductors and why energy gap is high in insulators and why energy gap is moderate in semiconductors. We will also conceptualize the electron and hole concepts in semiconductors. What is electron current, what is hole current, and we will also see why you are not having hole current in a conductor. We will also observe why you are not having any hole current in a conductor. Now, let's see what is energy gap. Energy gap means energy required to remove an electron from the attraction force of the nucleus. Consider this to be nucleus. Energy required to remove an electron from the attraction force of the nucleus. The valence band, it is closer to nucleus. If an electron is in valence band, it will be under the attraction force of this nucleus. If an electron is in conduction band, as conduction band is away from the nucleus, it will not be under the attraction force of the nucleus. So what is energy gap? Energy required to remove an electron from the attraction force of the nucleus or from valence band to conduction band. This is energy gap. In conductors, we can see that you are having number of free electrons. You are having number of free electrons. So you need not require to apply any energy to remove an electron. Energy gap is energy required to remove a electron from valence band to conduction band. So you need not require to apply any energy to have a free electron. Why? Already you are having number of free electrons. That is why Eg is 0. For insulators, the atom is already stable. It don't want to lose any electron. So to remove an electron from the attraction force of the nucleus, to remove an electron from this atom is not ready to lose. You have to apply a very high amount of energy. You need very high energy to pull an electron from this atom. That is why this Eg is very high, around 6 electron volt to 7 electron volt. Now in semiconductors, the Eg is in between conductors and insulators. This for semiconductors, the Eg is around 1 electron volt. So Eg is moderate in semiconductors. Now we will observe why you are having number of free electrons in a conductor. Why Eg is 0? Why you are having number of free electrons in conductors? Okay. Now in generally, so these are general terms. There are many other issues that we can observe. Generally, the atoms, they will try to stabilize themselves by having 8 valence electron or by having filled outermost shell. What atom will be trying to do? They will try to stabilize themselves by having 8 electrons in its valence shell or by having filled outermost shell. Now let's take the example of copper and observe why copper is a conductor. Now in copper, the atomic number is 29 and the orbital view is 1s2, 2 electrons, 2s2. In second orbit you are having 2 electrons. In this third orbit 2p6 you are having 6 electrons. Likewise in this valence orbit 4s1 you are having 1 electron. How many electrons you are having? 1 electron in this valence orbit or valence band. Now what this copper atom it will try to do is it will try to stabilize itself by having filled outermost shell. For that it don't want this electron. It wanted to push away this electron. This copper atom, it don't want this electron. This copper atom wants stability, and this for stability it don't want this electron. So what this copper atom it will try to do is it will try to push away this valence electron. Now when the temperature is greater than 0, when you are increasing the temperature, means you are applying energy in the form of temperature. Now if the temperature is greater than 0, this copper atom, this valence electron, it will absorb the energy from this temperature, and this copper atom it will push away this electron. Okay. What this copper atom is doing? This copper atom, it is taking the energy from this temperature and it is pushing away this electron. As it don't want this electron, it is pushing away this electron from its attraction force. Now you are having a free electron. This is a free electron. You are having a free electron. Now at room temperature, each and every copper atom, they will donate their electrons to crystal. What does it mean? They will push away their valence electrons. They will take the energy from the temperature. They will push away its valence electron. They will donate their valence electron to the crystal. Now how many electrons you are having in a copper? So as many as copper atoms. So the number of electrons in a given copper is as many as atoms. So that is why this copper is a conductor. You are having free electrons without applying any external energy. At room temperature, you are having number of free electrons. You need not require to externally apply any energy. You are having free electrons. That is why this copper is a conductor. Okay. Now let's observe why these insulators are insulators. Now for insulators, generally they will have 8 valence electrons are filled outermost shell. Now they are already stable. They don't want to lose their stability by losing one electron. Means they don't want it to lose any electron. They want it to be stable and they are stable. They are having 8 valence electron. Now to remove an electron from its valence orbit, you need a very high amount of energy. You have to apply a very high energy to pull this valence electron from the attraction force of the nucleus. You need a very high energy because it don't want it to lose. That is why this Eg is very high in insulators. Now what happens in semiconductors? Let us take the example of silicon and observe the conductivity of this semiconductor. Now these semiconductors, example are germanium and silicon. Now each silicon atom, they are surrounded by 4 other silicon atoms. In crystalline structure, 4 other silicon atoms. This silicon atom is surrounded by 4 other silicon atoms. And the atomic number of the silicon is 14. What is silicon atomic number is 14. So you can say 1s2, 2s2, 2p6, 3s2, 3p2. So how many valence electrons? 2 plus 2, 4 valence electron. So the silicon atom, it is having 4 valence electron. The silicon atom is having 4 valence electron. Now to get stability, how many electrons it want? It wants 4 extra electrons. It is having 4 valence electrons. The silicon atom is having 4 valence electrons. Now to get stability, it wants 4 extra electrons, 8 electrons. Now what this copper atom will do is, it is finding 4 silicon atoms nearby. Now each silicon atom is surrounded by 4 other silicon atoms. Now this silicon atom, it will share the electrons. The adjacent silicon atoms, they will share the electrons, and the electrons, they will form a covalent bond. Now this electron, it will belong to this silicon atom also, this silicon atom also. Now what this silicon atom is doing? To get 8 electrons, it is having only 4 valence electrons. So these silicon atoms, they are forming a covalent bond. Now this silicon atom is having 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Now this silicon atom is also having 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now at 0 degrees Kelvin, all electrons are in covalent bond. They are under the attraction force of this nucleus. You are not having any free electron at 0 degrees Kelvin. When you are not applying any energy, all these electrons, they are under the attraction force of this silicon. They are in covalent bond and you are not having any free electron. So at 0 degrees Kelvin, this silicon, it will work like as an insulator. You are not having any free electron. So the silicon is a insulator. Now what happens if you increase energy, if you increase temperature, what happens if you increase temperature? If you increase temperature, the electron present over here, any one of these electron, they will take energy from this temperature and it will come out from this covalent bond. You will be having an electron over here. Means if you increase temperature, the electron, they will take this energy from this temperature, it will come out from this covalent bond, or it will come out from the attraction force of this silicon. Now you will be having a free electron. Now in this covalent bond there is an absence of electron, which is known as hole. What is hole? The absence of electron in covalent bond is known as hole. The absence of electron in covalent bond is known as hole. Otherwise, one more definition is the atom should be ready to accept one electron. What is a hole? If an atom is ready to accept a electron, we can call there is a hole in that position. Now this silicon atom, it wants one electron to get stability. Now there is a hole over here. Absence of electron in covalent bond. You are having a free electron. Now this is what happens if you increase temperature. Now, generally, in 1 centimeter cube, the atomic concentration, you will find 5.0 into 10 to the power of 22 silicon atoms. So in 1 centimeter cube, how many silicon atoms? 5.0 into 10 to the power of 22 silicon atoms you are having. And how many free electrons? 1.5 into 10 to the power of 10 free electrons and holes. As you are having one free electron, it means you are having one hole also. So how many free electrons are holes? 1.5 into 10 to the power of 10. How many atoms? 10 to the power of 22. How many electrons? 10 to the power of 10. If I divided this first term by second term, what I will get is 3.3 into 10 to the power of 12. Okay. What does this mean? This means for 10 to the power of 12 silicon atoms, you are having one electron hole pair. One electron hole pair. Not that each and every atom is having one electron and hole pair. For 10 to the power of 12 silicon atoms, you are having one electron hole pair. Silicon atom. Second silicon atom. Likewise. After 10 to the power of 12 silicon atoms, you will be having one free. This covalent bond will be breaking. You will be having one electron and one hole. Free electron and free hole. See the difference between a copper and silicon. In copper, at room temperature, each and every copper atom has donated one electron to crystal. Whereas in silicon, 10 to the power of 12 atoms, for 10 to the power of 12 atoms, you are finding one electron, one hole. See the difference in conductivity, in number of electrons we are having. Oh, this is one concept. Now this is about this thing. Now by applying energy, you are having electron and hole. By increasing the temperature, you are having one electron and one hole. This process is known as generation. This process, the breaking of this covalent bond and coming up out of this electron from this covalent bond and a hole is being formed over here, this process is known as generation. Now because now this electron is free, this electron can roam freely anywhere in this crystal. This electron is free, it can move freely. Now while moving freely, if it reaches to this silicon, say if it reaches, now this electron, this atom, it wants one electron. It wants one electron to get stability. If this electron reaches this silicon, it will absorb that electron. And we are losing one electron and hole pair. The electron, it will come and it will sit in this position. Now we are losing one electron and one hole. This process is known as recombination. Because of energy, you are getting, because applying energy, after applying energy, you are getting a hole and electron, you are getting a whole electron pair. After recombination, you will get energy. You will get the energy. Okay. Now let's observe one more concept, that is hole current. That is hole current. Let us apply a electric field plus terminal to this negative terminal to this. What we are observing is, we are observing current in a semiconductor. How current is flowing in a semiconductor. Now we are applying a potential to the semiconductor. On my this left side we have connected positive terminal, on right side we have connected a negative terminal. Now what happens is, this free electron will move towards this positive charge. Now this free electron will move towards this positive charge. Now you are having an electron current. Electrons are moving from right to left, minus x direction. Electrons are moving in minus x direction. This electron will move towards this positive. This electron also will move towards positive, minus x direction, towards my left. Now current will be, I can call, there is an electron current. Electron current is in which direction? It is in plus x direction. There is an electron current in x direction. Electron current direction. So this is known as electron current. Now there is one more concept in this, that is hole current. What happens is, the moment you are applying energy, now this covalent bond will break. Which covalent bond? The covalent bond present over here will break. The electron, it will come and occupy this position, and you will be having a hole over here. And what happens next? This covalent bond, it will take energy from this electric field. The electron over here, it will break. The covalent bond over here will break. This electron will come over here. It will occupy this position, and you will be having a hole over here. Now I can see that previously my hole is here. Now my new location of hole is this. Now I can say my hole is moving from left to right on positive x direction. So what actually happening is, my electron is moving in covalent bond in negative x direction. The electron from here, it has moved in this place. The electron which was over here, it has moved to this. So what is happening is, exactly happening is, the electron is moving in covalent bonds. Now how it appears? It appears something like the hole has moved from this location to this location. Now this current is known as hole current. In hole current also, the electron in covalent bond, it is moving in minus x direction. So the hole current, it will be in plus x direction. Now your total current is because of the free electron movement towards this positive charge, and the whole movement towards negative charge. The hole is moving. Previously the hole is here. Now the new location of the hole is here. Now the total current is, the electron, because of the total current, because of electron is moving towards this positive charge, whereas the hole is, it is moving towards negative charge. What is the meaning the hole is moving? It means the covalent bond, the electron, it is moving in covalent bond. If it is moving in covalent bond, we can call it as a hole current. Now one more point to be noticed over here is, the hole current, it is less compared to electron current. Why? The electron over here, it is not under the attraction force. It can move freely. No other forces on this electron. It can move freely. Whereas for this process to happen, for this, previously the hole over here, the electron, for this process to happen, for the movement of electron from this position to this position, first a covalent bond is required to be broken. Now a covalent bond has to be broken. After that, it has to take this new place. Now you need some energy to break the covalent bond, to move electron from this location to this location. What you have to do? You need to break first this covalent bond, free an electron. Now that free electron had occupied this hole. Now you need some energy to break this covalent bond. You need some energy to break this covalent bond. After that, this electron, it is taking this new position. Now you need some energy to break this covalent bonds. That is why the hole is moving a little bit of slow. The hole current is less. Why? The hole is moving slowly. You need some energy to break this covalent bond, and electron has to move. Now the electron in covalent bond, it is moving slowly. whereas this free electron is moving fast. That is why this electron current, the current because of this electron is high compared to current because of hole. Because this electron in covalent bonds, it is moving slowly. Generally, the electron current, it is 3 times to the dot 2 of this hole current. This electron, it will move 3 times faster than this hole. As the electron, it is moving freely, as it is moving fast, we can say the electron mobility is high compared to hole mobility. The hole is moving slow, so we can say the hole mobility is less and the electron mobility is high. By what factor? Generally 3 times. The hole mobility is 3 times less than that of this electron mobility. Now the total current in the semiconductor is because of electron current and because of hole current. In hole current also, the electron is moving in minus x direction but in covalent bonds. Okay, the total current is in semiconductors electron current plus hole current. Now, so this ends the lecture on semiconductors. Before ending this class, let's observe the small point. Why you are not having a hole current in copper? In copper also, this copper, it has lost 1 electron. It has losing 1 electron. Why you are not having a hole? The absence of electron, if we can call it as a hole, in copper also you are having the absence of electron in this valence orbit. In this valence orbit, you are having a absence of electron. You are not having any electron in this valence orbit. Why you are not having a hole in copper? Why you are having a hole in semiconductors? Why you are having a hole current? This hole current concept started from semiconductors. In copper, you are not having hole current. Why? Just go back and analyze what is the definition of hole. The hole means the absence of electron in covalent bond, or the atom should be ready to accept a electron. Now this silicon atom, it needs 1 electron to get stability. It needs 1 electron. Now if some electron comes from nearby, this silicon atom, it is ready to accept. It wants stability. It is having 1, 2, 3, 4, 5, 6, 7 electrons. It wants 1 electron. If 1 electron comes closer to this silicon atom, it is ready to accept, and it is accepting. It is accepting this electron. It is accepting. So that is why there is a hole current concept in silicon. This needs 1 electron to stabilize itself. Whereas in copper, this copper is not ready to accept any electron. The copper itself purposefully pushed away this valence electron. It don't want any electron. Now if some electrons come to this copper atom at room temperature, if some electrons come to this copper atom is not ready to accept. I will not take, I am already stable. I don't want any electron. So as this copper atom is not ready to accept any electron, there is no hole current concept in conductors. Whereas in semiconductors, you are having electron current plus hole current. This ends the lecture on semiconductor. If you are having any doubts, the conceptual doubts, whatever may be the doubt, whatever the small doubt you are having, you can mail me to this following mail ID, or you can give a call on to this number 966096 And for gate preparation, how to prepare for gate, what are the tricks, how I should plan, how to crack. So for all this analysis, for all this guidance, you can give a call.